All right, fifth grade. It's Tuesday, the 26th of May, 2020, and we're looking at our science for today. We're continuing to work on the chapter called Weather. We won't finish it, but we're going to learn as much as we can. Okay, so I'm at 8.3, the atmosphere, the cloud factory. Also, just because it's our last full week of school, all you need to do, I didn't create templates for you. I didn't want to push that. At this point, all you need to do is put the answers. Okay, you've been faithful to work hard all year. So all you have to do for this is to put the answers. But really think about it, because I still want you to learn in context. We're not just writing down anything. Really think about what the question is asking you, etc. But this is pretty intensive, and you know, I'd rather spend our time reading, and I'm going to point out as much as I can. And like, you know, like I always tell you, you can watch the YouTube over and over or whatever you need. All right, so we're at 8.3, the atmosphere, the cloud factory. It says, did you know that an average-sized white fluffy cloud can weigh as much as 1,000 tons? 1,000 tons, and yet it stays up in the sky. What kind of material is a cloud made of that such a heavy object can manage to float, like I said, so easily through the blue sky? A cloud is not made out of water vapor, not. As you may have heard, water vapor is an invisible gas. Rather, a cloud is made out of very tiny water droplets. These droplets are so small that it takes over 1 million of them to make up one raindrop. So 1 million to make one little raindrop, 1 million of these droplets. But where do cloud droplets come from? And how do they manage to get high into the air? The cool blue sky. Did you know that it snows at the equator? There are several tall mountains in the tropical regions that have snow on their tops. Snow falls at the tops of high mountains because, although the temperature at ground level may be much too warm for snow, the mountains reach high up into the upper levels of the atmosphere where temperatures are cold enough to allow snow to form. So there's a picture of snow on Mount Kilimanjaro in Tanzania, Africa, at the bottom of your page 215. Warmed by the sun, the earth radiates energy back into the atmosphere. Air in the lower troposphere absorb most of this energy, allowing very little to pass on to upper levels. At higher altitudes, because air is farther away from the Earth's heat, it is much colder than the air near the Earth's surface. And that makes sense. It's logical. The temperature of the air at the troposphere's topmost boundary, called the tropopause, is between 60 and 80 degrees below zero. Okay, so we looked at our spheres, gosh, way back. Let me see if I can find it real quick. On page 197. Okay, we see our spheres. And we see the troposphere, so, which is where we live, okay, where we can get enough air and whatnot, because we know that oxygen depletes as you go higher into the spheres. But at the top of the troposphere, it's colder, obviously, than at ground level. So that's basically what they're saying. All right. So it says the tropopause marks the location of the temperature inversion. A temperature inversion is a reversal in the direction of temperature change with a change in height. In the troposphere, as a general rule, the warmest air is found near the Earth's surface, like I just said, and the coldest at the tropopause. Okay, higher altitude. The higher the air, the colder its temperature. But above the tropopause, heat-absorbent ozone causes the air in the stratosphere to become gradually warmer. Later, we will see how the temperature inversion at the tropopause acts like a lid to keep the weather brewing in the troposphere from penetrating higher up into the stratosphere. So you can look at this picture here, and you see the cooler weather is going to be the deepest blue, and the warmer weather is going to be where you got up here where it's yellow. Okay, and you can see the temperature, you're below zeros and you're above zeros, and you can see how the temperature fluctuate, where it's warmer and where it's cooler, which is what we just talked about. All right, so let's turn the page. A recipe for clouds. There are usually 3 main ingredients needed for cloud formation: water, rising air, and dust. This combination is not very difficult to achieve because God has designed clouds to be the means of watering the earth. Okay, we know that as the water evaporates and creates clouds, that's the main way that we get precipitation: snow, sleet, hail, rain. And so 3 recipes for clouds: water, rising air, and dust. So let's look at those 3 ingredients. It says the first ingredient required for cloud formation is water. Through evaporation, like I just said, water is placed into the atmosphere as a vapor. Most of the water vapor remains in the bottom of the troposphere, very close to the Earth's surface, where evaporation takes place. Remember that warm air is able to hold more water vapor than cold air. That means that near the Earth's surface, where temperatures in the troposphere are the warmest, air can hold a great deal of water vapor. Higher up, though, the colder air is not capable of holding nearly as much. So the second ingredient needed to make a cloud is rising air. When warm air begins to rise away from the Earth's surface, it takes its water vapor along with it. But as the warm air rises, it begins to cool. Soon it reaches the dew point, the lowest possible temperature at which it is able to hold all of its water vapor. We talked about that last week. If the air rises and cools any more, it has to get rid of some of the water through condensation. Water vapor condensing high in the air forms a cloud. But there is a third ingredient in the cloud recipe. Without this particular item, clouds could not form because condensation would be impossible. In order for water vapor to condense, a solid object must be present for the water molecules to collect as a liquid. For instance, water may condense onto the outside of a glass or onto a car window. We talked about that last week. But there are no such objects floating around in the sky where clouds form. You don't have your windshields or your glasses. How then does condensation take place high in the air? Let's look at the picture here. I'm on page 217. The air is full of countless microscopic particles of dust, sea salts, volcanic ashes, pollens, and other substances. These dust particles provide water molecules with billions of tiny solid surfaces for condensation. So the condensation basically takes place on these teeny tiny dust molecules that are made up of pollen, it said dust, volcanic ash, sea salts, etc. When rising air cools below its dew point, its water vapor condenses to form very small droplets of water around the dust particles. Because of the smallness of these water droplets, they are able to stay suspended in the air without falling to the ground. We see them as a cloud drifting gently across the blue sky. Okay, so here on page 216, we see our recipe on a recipe card. For clouds, we need water, rising air, and dust. So you see bake air near the Earth's surface in the sunshine at a warm temperature. Stir in water vapor, allow to rise and cool. Add dust, makes at least one cloud. Okay, so that's a cool way of thinking about it, of putting it. All right, so if you look at the picture, it's going to show you your condensation. So here you have your, it says, your step 3 here, your condensation level, air at dew point, temperature, and then you see how it forms clouds, each picture coming from the earth, going higher into the atmosphere, etc., mixing with the water, with the warm rising air, and with the dust particles in that in those higher spheres, which are made up, like we said, volcanic ash, sea salts, and pollens, and other things too. so moving up in the world. Now that we know clouds form when moist air rises, we need to talk about the different things that can cause air to rise. First thing, solar heating, heating from the sun. When we talked about winds in the last section, we learned that the sun's heat produces rising air. Solar energy beaming down from above heats a certain area of the Earth's surface hotter than the surrounding areas. The hot Earth then makes the air above it warm. The warm air is pushed upward by the cooler air around it. As the air rises, its water vapor condenses to form clouds. On the large scale, the tropics are the warm spot where air rises to form clouds. Remember that air over the equatorial regions is warmed and lifted by the sun before beginning its journey towards the north and south poles as a part of the wind system. We talked about that. Much rain falls in the tropics because large amounts of water vapor are changed into heavy rain clouds as the ascending, that means going upward, air cools. But on a smaller scale, a parking lot or field is also capable of making its own cloud by the same method. Have you ever seen the sky dotted with lots of little puffy white clouds on a hot summer day? Yes. Each of these clouds was made when a bubble of warm air over a certain sun-heated area of land rose upward. Remember, heat rises, releasing its water vapor by condensation to form a cloud. The flat bottoms of the clouds show at what height the temperature of the air fell below the dew point. The flat bottoms, okay? That's where it formed into the dew point, where it made that connection. If you watch these clouds closely for some minutes, you can see them growing in size while the ground continues to supply hot air. Then, as the wind carries them away from their birthplace, they gradually melt away into nothing. Okay? We're going to go over each of the questions and look for our answers, but you should be getting kind of a general idea. So, mountains. When the wind blows across the earth, remember the three wind systems, it often runs into obstacles in its path. Okay? Usually, if the obstacle is small or narrow, the wind will flow around it. It can move right around it. If wind was blowing over my ruler, it's narrow, it's small, it could flow right around it. Okay? But mountains are larger. So let's read about that. But if the obstacle is big enough, like a row of mountains, the wind may have to flow over it. It can't go around it. As moving air rises over the barrier, the mountain range, it cools and releases some of its water vapor to form a cloud. Many mountains are constantly covered with clouds because of this action of the wind passing over them. So you can see the picture here. The wind has to go over the mountains here. You could see the wind blowing the arrow and how these clouds are produced. Fronts. Clouds are also made when warm air and cold air run into each other. The Earth's winds are what causes these different types of air to collide and mix. We talked about that. Remember that both the northern and the southern hemisphere are divided into three main wind belts. The trade winds, closest to the equator, the polar easterlies, which bring the cold air to mix with the warmer air, and then the prevailing westerlies in the middle latitudes that mixes the cold and the warm up, cycles it in the middle latitudes between the trade winds and the polar winds, like I said. Of the three wind belts, the area of prevailing westerlies in the middle latitudes has the greatest variety in the weather. We talked about that last week. In this region, air flowing away from the equator runs head-on into air flowing the opposite direction, away from the poles. The constantly changing weather is a result of the colliding, jostling, and mixing of huge masses of warm tropical air and cold polar air taking place overhead. The huge masses of air that collide in the middle latitude form over source regions. Form over source regions. A source region is a large area of land or ocean with nearly the same temperature across its entire surface. the air directly above the region takes on the characteristics of the terrain or the ground below it. If the terrain or the source region is cold, the air cools. If the terrain is warm, the air also warms. If the terrain is moist, the air picks up water vapor. The air over the region continues to change until it becomes what is called an air mass, which is a single large unit of air with uniform temperature and humidity characteristics. There are many different types of air masses. Before I explain that to you, let's read more. A continental tropical air masses are hot and dry, forming over the deserts and plains of sun-heated continents, especially in summer. Near the equator, maritime or tropical air masses pick up much moisture from warm seas. And it says the colder oceans outside the tropical regions produce maritime polar air masses with cool, wet air. Cold and dry continental polar air masses form over large areas of land such as Siberia and Canada in the northern hemisphere. Arctic and Antarctic air masses, which develop over the ice and snow of the poles, have very cold and rather dry air. Look at the map to see how these different kinds of air masses influence the weather of the United States. Okay, so if you look at the picture here, you could see the different air masses. We have maritime tropical near the equator, maritime tropical down here, tropical, maritime polar, continental tropical, maritime polar. This is the United States right here. Maritime polar, you could see we have more polar to the north, more tropical to the south towards the equator. And like it's saying, when you have terrain or ground levels, okay, that are, I want to read exactly how they describe it. These source regions, because they're going to kind of determine what the weather pattern will be. It says above the air, directly above these regions, the terrain, the ground below, whatever it may be, if that source is cold, the air will be cold. If the source around it is warmer, the air will be warmer, okay? The air over these regions will continue to change until it becomes what is called an air mass. So that mixing, which is a single unit of air with temperatures that are uniform, meaning basically the same. So the maritime tropical is going to be basically hot, wet air. The polar, okay, the maritime polar and continental polar are going to be colder, okay? It's uniform. I'm here now. It says, I'm on page 219, after some time, the air mass may begin to move away from its source, okay, that ground terrain that it was over, from its source region, traveling very slowly. As an air mass moves, it gradually picks up the characteristics of the terrain that it passes over. For instance, if an air mass forms over a hot desert, its air will be hot and dry, like we said, which is a continental tropical. But it then moves out over an ocean, it becomes warm and moist, like the maritime tropical. So it depends on what's below it. Is there water below it? Is there ocean below it? Is it near the equator? When it talks about the continent, that means land, okay? So if the air, the land is hot and dry, then the air masses around it will be hot and dry. If it's wet and warm, like near the tropics, near the equator, it's going to be warm and moist. Most often, air masses move toward the middle latitudes. In the middle latitudes, an air mass cannot travel far before bumping into other air masses. Usually different air masses have different characteristics. One will have warmer air than the other, for instance. When two air masses meet, a very definite boundary line forms between the two different types of air. The hot dry air, or the cool moist air, or the hot moist air, or the cool dry air. The boundary between two air masses is called a front. There are different types of fronts, depending on which air mass is moving forward and pushing back the other. Like, get out of my way. At a warm front, warm air pushes back cold air. But at a cold front, cold air pushes back warm air. You might have heard, like on the news, it'll say there's a cold front that's coming from the north, or a warm front that's coming from Mexico, okay? The warm air is pushing the colder air back, or the cool air is pushing the warmer air back, okay? Depending on what's happening. So it says when advancing warm air runs into a mass of cold air, it slides up over a mass of colder air. It slides up over the top of the cold air in a very thin wedge and begins to push the cold air slowly backward. Look at the picture on the bottom of page 219. As the warm air rises, it cools and releases some of its moisture through condensation to form clouds. The clouds form at the boundary between the warm air and the layer of colder air beneath it. At the tip of the wedge of rising warm air, the clouds are very high and thin, but they lower and thicken as the warm air gets closer to the Earth's surface. From your viewpoint on the ground, a warm front appears as a long period of cloudy, rainy weather, sometimes lasting several days and followed by warmer temperatures. Okay? Just because it's warm, it doesn't mean it's not cloudy, or it's not. Think about humidity. Some of the most humid days, like if you're ever in the southeast, the most humid days, it's thick clouds, a lot of rain, there's a lot of humidity in like islands like Hawaii, etc., where even though it's warm, it's in the 80s, it's raining. Okay? So cold fronts travel more quickly than warm fronts. Heavy cold air moves forward at ground level, bulldozing into the lighter warm air and pushing it rapidly upward. Very tall rain clouds build up in a narrow band along the edge of the rising warm air. Cold fronts bring a short period of rainy weather and are usually followed by clear skies and cooler temperatures. Often the weather of a cold front is severe with heavy rain and wind, lightning, thunder, and maybe even hail or tornadoes. Okay, so much information there. The best way to understand it is to look at the illustrations. Okay, so if we look at what we just read, I pointed out the others to you. But if you look here, we talked about the warm air. It's like on a wedge. It looks like it's on like a plank or a teeter-totter in this picture. The warm edge, this is a warm front. Warm air is coming. The cooler air is below it, pushing it down on a warm front. And then here on the next page, you see the cold front crashing down, bulldozing. Think of a bulldozer with, big metal that like it turns up the ground, and it's really powerful. So this looks like it's coming up over the top of that warm air and just cutting it off. Okay. And so you get the two examples. That's why a cold front might have a more dramatic weather pattern, like it talked about the thunder, the lightning, the heavy rain, maybe even tornadoes. So you can see the warm air, it's a gradual coming up over the cold, but the cold, it's crashing down. Okay, so that will determine different kind of types of storms, cloud coverage, etc., how humid it is, etc. All right, so I want to read the highlighted parts one more time to you before we look at the comp check. So we see the tropopause, which is the temperature of the air at the troposphere's topmost boundary. I showed you a picture of that above the tropopause, and that is cold, between 60 and 80 degrees below zero. We have temperature inversion, which is inversion is a reversal in the direction of temperature change with a change in height. We have the three ingredients in clouds, which we have water, rising air, and dust. We have a lot of cool pictures to explain. It talked about warm fronts, air masses, mountains, and how the clouds form above them and why. We talked about that. We Talked about source regions, which is the terrain, the ground under certain places. If it's warm, I want to read that part too again because I thought that was really cool to think about. So the huge masses of air that collide in the middle latitudes form over source regions. A source is like an answer. If you have a headache, the source of a person's headache could be their sinuses or what's the source? Jesus is our source. Okay, that's the best example. The main thing. So a source region. A source region is a large area of land or ocean with nearly the same temperature across its entire surface. The air directly above the region takes on the characteristic of the ground below, because that's a source. That's the main event there. If the terrain of the source region is cold, the air will be cold. And if the terrain is warm, the air also will be warm. If the terrain is moist, the air picks up the water vapor. The air over the region continues to change until it becomes what is called an air mass, which is a single large unit of air with uniform temperature and humidity characteristics, meaning the same over this huge region, it's going to be pretty much the same temperature and the same percentage of humidity. We talked about continental tropical air masses are hot and dry. We talked about maritime tropical air masses or pick up a lot of moisture from the seas and it's colder. We talked about, colder oceans maritime polar, think of cold polar, and continental polar, or air masses that form over the land areas, large areas of land, such as it says Siberia, Canada. Then we have the Arctic and the Antarctic air masses. We have the boundary between two air masses is called a front. We talked about a warm front, comes up like in a wedge. I think it looks like, it reminds me of a teeter-totter. Comes up over a wedge, pushes the colder air down, just comes up and over it. And we see that cold front pushes the air back. We see the cold front, it crashes down, pushing the air, it bulldozes it out of the way. Those are our main terms here. So your comp check, it's a lot of questions, but you don't have to put it in complete sentences. You could just put the answers. So let's do a good job on this. Don't just slop this together because I'm making it easier, or that will make me think I shouldn't have done that. I should have given them their last full week of school, these lengthy writing templates. Okay, so I'm trusting you to work just as hard even though you don't have a template. So in section 1, you'll put true or false. Like number 1 says, most collisions between air masses take place in the middle latitudes. We read that is true. Remember the polar, think about the trade winds, or the winds, the polar easterlies, polar, and then the equator, and then it mixes up mostly in that middle latitudes. Okay, so that is true, so you'd write true. B, warm air grows warmer as it rises. Well, we learned that warm air rises, but as it gets higher and higher, we talked about that tropopause, that troposphere, it actually gets colder. So that would be false, okay? So you write true and false for A through G. In number 2, it says identify each statement as a characteristic of a warm front or a cold front. So you're gonna write warm front for your answer or cold front, okay? So letter A says warm air pushing back cold air. Well, we know the warm air pushing back the cold air, look at our picture, is a warm front. It's pushing back. It's coming up over and pushing back the cold air. So we know that is called a warm front. So you'd write warm front. For B, number 2B, cold air pushing back warm air. We saw this here. Cold air crashing over warm air is called a cold front. So you're going to write warm front or cold front, depending on what it is, on 2A through G. Number 3, what are the 3 ingredients in the cloud recipe? We read that it's water. We read that it's dust and rising air, okay? For number 4, name 3 things that cause air to rise. Look at section moving up in the world. And this says, now that we know clouds form when moist air rises, we need to talk about the different things that cause air to rise. We talked about solar heating. We talked about the mountains, causes the air to rise and therefore forms a cloud, and we talked about fronts. Okay, so those are the three things that cause air to rise. Number 5, what is the name of the upper boundary of the troposphere? We found that on page, back in the beginning, on page 215. Read here. We talked about the temperature of the air of the troposphere's topmost boundary is called the tropopause. Okay, and then number 6, what is an air mass? All right, so look what it says here, right here on page 218, air mass. It says a single large unit of air with uniform, meaning pretty much the same temperature and humidity characteristics. Think about your school uniform, it looks the same. So when it says that the temperature and the humidity is the same, it's going to be the same temperature, basically the same percentage of humidity. All right, so I went through all of that with you. Do a good job. It's so much information, and I wish I could explain it better. It's so much easier to do in person with you, but look at the pictures. If you have any questions, call me, reach out to me. Do a good job.